Welcome back to my YouTube channel. My name is Mohammad Ubaid and this is another video of basics of structural analysis series. And today in this video we are going to solve a very important problem, which is a doubly overhanging beam with a concentrated moment at end C and another point load at end D. In this problem we are going to find the slope at A and we are going to find deflection at D by using moment area method. So without any further delay, let's get started with the solution of this problem. So this is our problem. Now, as usually, first of all we have to draw the bending moment diagram of the given problem. Okay, so in this problem this support is B, sorry, this support is A and this is B and this is D and this end is C. Okay, so for finding the reaction at A, this is RA and this is RB. Okay, for finding the reaction RA and RB, first of all let us consider the sigma m about B is equal to 0 and taking clockwise direction as positive. Okay, now for this condition, what are the moment which we are getting? First of all we have this 40 kilonewton per meter, 40 kilonewton meter of concentrated moment. Okay, so this is working in anti-clockwise direction. Okay, so we have to take it as negative. Okay, this is working as in anti-clockwise direction, so we have to take it as negative. And further we have a reaction of RA. Okay, and RA, the distance is from A to B is 3. Okay, so it will be 3 and it will be positive because it is working in clockwise direction about B. And after this we have a 10 kilonewton of 10 kilonewton point load. Okay, which is acting at D, and the moment due to this load will be positive because it is also working in clockwise direction, so it will be 10 times 3. Okay, so from here RA into 3 will be equal to plus 40 minus 30 and it will be 10, and from here RA will work out to be it will be about 3.33 kilonewton. Okay, now the other equation which we will use sigma Fy is equal to 0 and we will take upward as positive. Okay, this means that the forces acting in upward direction will be taken as positive. Okay, so we have RA, we have RB in upward direction, and we have minus sorry, we can write it like minus, or we can just put the value in the equal on the other side of equality. Okay, like this. Okay, or for simplicity let me write it as minus 10 is equal to 0. Okay, because RA and RB are working in upward direction and 10 kilonewton is working in the downward direction. Okay, so we can just put the value of RA in this equation, which is 3.33, and from here we can work out the value of RB. Okay, so RB will be 10 minus 3.33 and it is equal to 6.67 kilonewtons. Okay, so in this way we have got the value of RA and we have got the value of RB. Now we can draw the bending moment diagram for this question. Okay, so we have got the value of RA, which is equal to 3.33 kilonewton, and we also have got the value of RB, which is equal to 6.67 kilonewtons. Okay, now we can draw the BMD or M by EI diagram for this problem. So let us consider that this is our horizontal line or reference line, and this is A and this is B and this is D and this is C. Okay, now if I want to find out the value of moment at B, so let me write it as MB. Okay, from right hand side, what is the value of moment at B? So it will be 10 times 3. Okay, the moment will be due to this 10 kilonewton load and multiply by 3 meter. Okay, so it will be minus 30 kilonewton meter. Okay, so we have got the value of MB, and what will be the value of MA? Okay, so at MA the value of moment will be minus 40 kilonewton meter. Why? Because at C, if I see from the left hand side, so the only load which is acting here is 40 kilonewton meter of concentrated moment. Okay, so only this moment will create the bending moment at A, and it will be equal to minus 40. Why? Because it is working in a manner that this concentrated moment will create a hogging moment at A. Okay, because it will try to deflect the beam like this. Okay, like this. So that's why we have to take this moment as negative. Okay, that's why we have to take this moment as negative. Okay, so I hope you have understood why we have taken this as negative. Now we have got the value of MB and MA. Now we can draw the bending moment diagram for this beam. So at B we have got minus 30, so it will be like it will be somewhere here, and at C we have got a value of minus 40. Sorry, MA we have got a value of minus 40, and at MC it will also remain 40, because here we have concentrated moment, and this moment will remain same from C to A. Okay, so here we will have a straight line like this, and from A to B we have a uniform straight line, and this will continue up to D. Okay, so here we have 30, or I will add it as EI divided by EI, and here we have 40 upon EI. Okay, and this will be closed here. Okay, so in this way we have got the M by EI diagram, so it will also be negative. So it is our M by EI diagram. Okay, now we have got our M by EI diagram, so we can proceed in our problem for further solution. Okay, so let's see how we will do this. Okay, we have got the M by EI diagram for this problem. Now we will draw the deflected shape of this problem, because as we know that moment area method is a semi-graphical method, and we have to have the deflected shape of the problem for solving our problem. Okay, so this beam, how will it deflect under this type of loading? Because here we have a load which is acting downward, and we also have a moment which is acting downward, or which is creating hogging moment. Okay, so this beam will deflect something like this. Let me draw it perfectly, because it will create problem if I don't draw it right. So it will go somewhat like this. Okay, so like this is our B, and this is A, and here it is C, and it is our D. Let us call this point as D dash on deflected shape. Okay, and let us call it as C dash. So this is our deflected shape. So this is the deflected shape of this problem. Now what are the parameters which we have to find in this problem? So we have to find theta A, we have to find deflection at D. Okay, now how we are going to find these two parameters? So if I try to draw a tangent at A, so it will go something like this. Okay, it will go something like this up to here. Okay, so what is this? This is our angle up to here from the horizontal line. So this is our angle theta A. Okay, and what is this? This whole from let us name this as D dash. Okay, this line is tangent at A, because we have drawn it at A. Okay, so this is our point A, and we have named this point as D double dash, and this is our D, and this is our D dash on elastic curve. Okay, so from here what can I observe? And one other important thing, what if I drop a vertical line here like this at B? So what is this value? This is TB over A. Okay, what does it mean? It means that the deflection, or that the deviation of point B with respect to the tangent drawn at A. Now from this figure one can easily see that what is the value of theta A. So theta A will be equal to TB over A divided by AB. Okay, and we know the value of AB, which is 3 meter. Okay, but we don't know the value of TB over A, which we have to find, so that we can find the value value of theta a. Okay, so let me write it here. So TB over a, it will be equal to am x bar upon ei. Okay, uh, from where to where? Okay, what is the value of am? So am is the area of bending moment diagram from a to b about b. Okay, because we have to find out the deviation at b, so we have to take the distance of cg, which is x bar from b. Okay, so let me find out this value. So from here, what will be the value of am? Okay, so as we can see in this figure, which is our m by ei diagram, so the area which we have to find it this area. So this is our area. Okay, this is a trapezoid from a to b. Okay, and what are the values of this trapezoid? So it is minus 40 upon ei, minus 30 upon ei, and this distance, it is 3 meter. Okay, so basically we have to find out the area of a trapezoid, which is like this, and here it is minus 30 upon ei, and it is minus 40 upon ei, and we have to take the x bar from b. Okay, clear? So from here I can easily write 1 by 2, the area 1 by 2 minus 40 upon ei minus 30 upon ei times the distance, which is 3 meter. Okay, this length, it is 3 meters. Okay, and multiply by x bar. What will be the value of x bar? For a trapezoidal, we have the formula for finding x bar, which is, let me draw it figure first. So it is a and it is b, and if we assume that this is h and we are measuring x bar from this side, so it will be x bar will be equal to a plus 2b upon a plus b times h upon 3. Okay, so from this formula we can write, for our problem, the x bar will be equal to, what is the value of a? Okay, so a is minus 30 and b is minus 40 times 2. Okay, it will be 2. I am not considering the ei because it will cancel out. Okay, from denominator and from numerator. Okay, so in denominator it will be minus 30 minus ei times 3 upon 3. Okay, now let me just calculate this value. So it will be about minus 1.57, and minus will be cancelled out from denominator and from numerator. Okay, so it will be 1.57 meters. Okay, so I can just put this value in the formula for TBA. So it will be minus 70 upon EI times 3 times 1.57. So from here we will get the value of TB over A as 165 by EI. Okay, now we have got the value of TB over A. So from this formula we can find out the value of theta B over A. Okay, so let me just find out the value of theta B over A. So theta A. Let me find out the value of theta A. So theta A will be equal to TB over A by AB, and it is minus 165 by EI whole divided by 3. Okay, so it will be minus 55 by EI. Okay, now we have got the value of theta A. The parameter which has remained, which we have to find, is delta D, deflection at D. Okay, now let us see how we will proceed for this task. So we have got the value of theta A. Now we have to find the deflection at D. Okay, so this is the M by EI diagram, and this is the deflected shape for our problem. So what is the deflection at D? So this value, so delta D is equal to D dash. Okay, we have to find out this value. Now how we will find out this value? So from this figure, if we focus on this figure, so this value up to t double dash to d dash, this value is t over a, okay, which means that the deflection of d with respect to the tangent drawn at a. If we found out this value td over a, then we can easily find out this value dd double dash. And how we will do this? So first of all, let me find out the td over a. So td over a will be equal to am x bar upon ei, okay, from what will be the value? Okay, so we have to consider this from a to d, because we are finding td over a about d. Why? Because we are finding the deviation at d. Okay, so this a by ei, this value we can get from this diagram, and x bar we can also get from this diagram. Okay, so first of all, we will consider the area in two parts. First of all, we will consider from a to d, and then we will consider from, sorry, first of all we will consider from a to b, and then we will consider it the area of b to d. Okay, so if I consider the area from a to b, what will be the value of the am by ei? So as we have done in our previous task for finding theta a, so this value will be 1 by 2 minus 40 upon ei minus 30 upon ei times 3, which is the distance from a to b, and this is also 3. Okay, times x bar. Okay, now in this case x bar, we have to take the distance of x bar from d. Okay, so the value of x bar we have to take from d. Okay, so what will be the value of x bar from b for this trapezoid? From b, first of all we will find out from b, and then we will add 3 meter so that we can measure it from d. Okay, so it will be 30 plus 40 times 2 divided by 30 plus 40. Okay, so this value, sorry, it will be multiplied by h by 3. Okay, plus 3. Why we have considered 3? Because this value, this whole value is from b. Okay, as we have calculated here. Okay, so this value 1.57 is from b. It is from b, but we have to consider the distance x bar from d, because in this case we are measuring the deviation at d, so we have to add additional 3 meters. Okay, so in this way we can write the am by x bar for this trapezoid. Now the other area which we have to consider is this triangle. Okay, so we have to add it right here. So 1 by 2 times minus 30 upon ei in brackets, multiply by 3, which is the base. Okay, and multiply by 2 by 3 times 3. Okay, so from here, after calculating these values, we will get td over a as minus 570 by ei. Okay, so we have got the value of td over a. So we have got the value of td over a. Now from this figure, what we can see is this is our td over a, and this is our dd dash. Now the other, or we can write it like this. If I write here, just here, if I write here, so we can write it as d double dash plus d dash is equal to t over a. Okay, which means d double dash plus d dash, which is this, is equal to td over a. Okay, so if I write it here again, td over a is equal to d d double dash plus d d dash from here. And what is d dash? So d dash is our delta d. Okay, d dash is our delta d. So I can write it as plus delta d, and from here we can find out the value of delta d. So delta d will be equal to td over a minus d d double dash. Okay, now we have to find the d double dash. So it can be find out very easily. What is this? So this is our theta a, and we also know this distance from here to here, which is 6 meter. Okay, 3 plus 3, this is 6 meter. Okay, so in this triangle we can, from this triangle a d double dash d, we can find out the value of d double dash. Okay, so let me write it again here. So what is this triangle? This triangle is like this. So this is d double dash, this is d, and this is theta a, and this is our 6 meters. Okay, so from this triangle we have theta a is equal to d double dash by 6, and from here we can write d double dash will be equal to 6 times theta a, and the value of theta a we know is equal to minus 55 divided by ei. So from here we will get the value of d double dash as minus 330 divided by ei. Okay, after putting and after putting the value of this d double dash in this equation, we will get the value of delta d. Okay, now let me put the value of d double dash and dd over a in the given equation. So the value of dd over a was equal to minus 70 minus 570 divided by ei, and we have minus, and we have another minus here for d double dash. So after solving, we will get the value of delta d as minus 240 divided by ei. So we have got the deflection at and d of the member, and we have also got the slope at a by using moment area method. If you like this video, please subscribe to my channel and share this video. If you have any confusion regarding any point in this problem, please comment down in the comment box, and I will try to answer all your comment as soon as possible. Thanks for watching. We will meet in our next video.